Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying the session. We are enjoying a lot and we are learning a lot. We are learning each and every day, guys. So yeah, hope the same thing for you and we are enjoying each and every day. So guys, as always, like if you guys have any doubts, please ping us in the comment section. We will take up and we will solve your doubts because like we are here to help you. Okay. So hope like it is like nearly like 60 to 70 plus sessions you guys have gone from the basics like a scratch method where you guys learned about all the things that is related to data, where to collect the data, how to collect the data, what are the strategies to collect the data, how to clean the data, process the data and make the data ready for the model to digest. Everything we have seen. Okay, so everything related to data, I will say, playing with data we have completed. We have stepped into one thing further, like as sir is mentioning, always mentioning, like we will be moving to one depth, one more depth, like one level depth, where we have moved into a concept called the machine learning. We have discussed about what is machine learning, types of machine learning, what are the algorithms with it, and we are just learning in a manner theory, that is black box of each and algorithm together with the coding part. Hope you guys are enjoying. So today is a theory part of is a continuation theory part of boosting. So yeah, so guys, as always, like if you guys are watching this video, please make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay, so yeah, that's the one thing. So please watch every session video that we have done previously. And if you guys do this session, this is a continuation of XGBoost. So we have taken one more session, previous session. Please watch the video so that you can get a continuation. Okay, so without wasting any time, let us jump into today's session. It is like, as I already mentioned, this is a continuation of XGBoost um, algorithm. So we have seen the black box and now we're gonna see what is hyperparameter tuning in XGBoost algorithm. Learning rate, it controls the step size for parameters updates. Okay, we are having a unique parameters which is present in boosting, so gradient boosting, where it will increase the accuracy of a model. By tuning these parameters you can increase the accuracy of model. First thing, it controls learning rate, it controls the step size for parameter updates. Okay, so how faster or how quicker or how slower or how optimal your model to learn, that is what learning rate. Number of trees determines the number of weak learners in the ensemble. Okay, I see. I like you guys have an remembrance like gradient boosting is a collection of weak learners in order to make the strong learners. So number of trees determines the number of weak learners. Then tree depth defines the complexity of an individual decision tree. Like I will say individual, how much complex the individual learners are, the weak learners are. Okay, that is what tree depth. Regularization, it helps prevent overfitting by penalizing model complexity. Yeah, we whenever we train the model we will get the loss, right? If you apply regularization, loss plus some more loss, what happens means, already loss means the model has to retrain and make it perfect. If we get penalty also to the loss, then it will become, the model will become more careful that our output is not at all near to the point that the user expected, so it will have some penalty term together with the loss and it will train better. Okay, and it will generalize the things and it will help to overfit, to avoid the overfit. Okay, so these are the parameters, these are some of the necessary parameters that we are having in gradient boosting in order to like increase its performance and accuracy. Yeah, so that's what about this hyperparameter tuning in gradient boosting. Yes sir, over to you.
Yeah, guys, go and watch all the sessions 5 to 10 times and absorb the information, digest the information, and apply the information and concepts. So, if you have not subscribed to our channels, subscribe to our channels. Also, press the bell icon so that you will get notification for each session and build your long-term objective function, a vision for your life, what you want to become, and write in the comment section if you have any feedback for us to improve these sessions, and we'll be improving. So keep learning with persistency, consistency, and perseverance, and long-term vision for your life. Become a lifelong learner, and these are the aspects. Okay, so let us start hyperparameter tuning. Okay, So let's see first, let's split this word called hyperparameter. So hyper means different, high, like more than one. Hyperparameter, parameter means parameters, the parameters of the data. So we tune it, okay? We do tuning. So how we do it? With learning rate controls the step size for parameter updates. So that is the one of the parameter, like one of the aspects of hyperparameter tuning. Then we have number of trees. It determines the number of weak learners in the ensemble. Okay, ensemble learning, we are learning that gradient boosting, right? So in that hyperparameter tuning, so the number of trees that determines the number of weak learners in the ensemble. Okay, then we have tree depth that defines the complexity of individual decision trees. Okay, then we have regularization, so that helps to prevent overfitting, penalizing models complexity. So these are the components of hyperparameter tuning, guys. So remember them, and conceptually you need to understand deeply what and why. How is a cakewalk? Just understand at a meta level all these concepts deeply so that absorb them, digest them, and then we go for application. Okay, so let's move to the other section.
Sure, sir. Yeah. So yeah, let's see the advantages and limitations of this gradient boosting algorithm. High accuracy, so it can achieve state of art performance on many data sets. It's robust, so it is resistant to outliers and noisy data. Interpretable, it can be difficult to understand the model's decision making process, because like we are saying, like there will be multiple models as a weak learners, and the strong learner will learn from it. So these are something like which is difficult to understand. Computationally cost can be computationally expensive to train, because like we're gonna have multiple training sets together with the coordinates, and we need to work on GPU missions kind of thing when um, this kind of algorithm will work. So GPU is a simple thing. When we just need to combine multiple CPU, it is called as GPU. So there will be computationally heavy processing and also this cost. So these are the, whereas high accuracy and robustness are some of the advantages of this gradient boosting algorithm, and then interpretability and then computational costs are the disadvantages of this gradient boosting algorithm. Okay, hope you guys can understand. Yes, sir, over to you.
Yeah, so advantages and limitations, guys. So the advantages are the, okay, so let's understand that. High accuracy can achieve state-of-the-art performance on many data sets. That is what is the advantage. Robustness, it is again resistant to outliers and noisy data. So this is the advantage. Interpretability, that can be difficult to understand model decision-making process, and that is a limitation. And then you have computational costs, can be computationally expensive to train. So you need computational power, and that is the main like after everything else, like all the things, like if you want to like build a startup or a world-class company, the only expensive thing would be computational cost, guys. Rest you can be able to build, but when you have to train your model on billions of data sets, so you need very expensive computational, uh, like that would be a cost on that building that model. Okay, so that is the only thing which is limiting right now, but that will also with quantum computers, that will be also in future very, it will be very cheap also in future. But we need to have different phases if we are building a startup for AI, ML. Uh, so how we should have a proper strategy. Because the huge cost would be computational cost, guys. So that is the main thing you have to understand, and that is a limitation also. So let's move to the other section.
Yeah, sure, sir. Moving on, let's see the applications of this gradient boosting. First is financial modeling. Yeah, it predicts the card transactions, risks, and then fraud detection and market trends. Healthcare, it is very useful in disease diagnosis, and also like patient risk like stratification and treatment response prediction. Okay, related to healthcare, this XGBoost algorithm will be useful. In marketing, customer segmentation, chunk prediction, and targeted advertising. So these are also like some of the applications that are having for marketing using data science. And then we are having real estate, predicting property price, demand forecasting, and rise assessment. So these are the different applications that we can done for gradient boosting. Finance modeling is one of the industry that is that gets improvement due to AI. Healthcare, that gets improvement due to AI. Marketing and real estate, anything, okay, it get the knowledge of this gradient boosting, which will be applied to these applications. So these are the real life problems. As I always tell, like this slide will be able to accommodate only uh, 4 application, but like not restricted to this. There are n number of applications where this gradient boosting is used. So yeah, I hope like it's a perfect understanding, right? So yeah, sir, over to you.
So application of gradient boosting, guys. So it helps us in financial modeling. So financial sector, wherever you have to predict credit risk, your fraud detection, or market trends. So we can use it. Healthcare, disease diagnosis, patient risk, uh, and then we can for treatment response prediction, in marketing, customer segmentation, chunk prediction, targeted advertisement, like targeted audience, okay, as whatever as per your product and services. So then real estate, predicting property prices, demand forecasting, risk assessment, and n number of applications uh, where gradient boosting can be applied under these scenarios. So it can be a number of industries with these scenarios. Wherever we have these scenarios, so we'll be able to apply. Let's move to the other section.
Yeah, sure, sir. So moving on, yeah, let's conclude this. Okay, conclusion and future directions. Conclusion. So continued evaluation. New advancements in gradient boosting are constantly being made, improving efficiency and performance. I don't know like how many of you know the package. That is something called as a skillon, where you can find what are the models that it has fine tuned, what is the new advancement they did. It's like those things it will do. In a similar manner, we can create some like a storage kind of thing for storing the things. So for evaluation, like it gonna be a new advancement. So this boosting that is constantly being made, and it improves this like efficiency and performance. Interoperability. So efforts are underway to enhance the interoperability of gradient boosting models. Okay, so yeah, this is also one of the, I will say this is also one of the conclusion we can use this in order to improve the accuracy of our like any kind of data set. Okay, that is what conclusion I will say. One is like new advancements which are made in this gradient boosting, which makes it stand out and the top model. So then interoperability, where it is used to enhance this interoperability kind of thing by using this gradient boosting. And then scalability, it is scalable. Gradient boosting algorithm are crucial for handling larger data sets. Okay, so yeah, these are some of the conclusions and future work. Hope you guys are able to understand. Okay, it should be like new advancements, and it should be like something like interoperability finding by using gradient boosting. Scalability, so it is also an algorithm which is crucial for handling larger data sets. So yeah, these are about the conclusion and future work. Yes, sir, over to you.
Yeah, so conclusion and future directions, guys. So continued evolution is happening in the field in gradient boosting, okay, ensemble learning. We are learning this. So new advancement are there in gradient boosting, which are constantly being made, improving efficiency and performance. Then interpretability efforts are being underway to enhance the interpretability of gradient boosting. That is improving also. Scalability of gradient boosting algorithms are crucial for handling larger data sets. So that is also been research has been going on to improve these things. One is continuous evolution is happening, interpretability and scalability. So let's move to the other section.
Yeah. Sure, sir. So, like, yeah, I think this is the final slide. We have concluded. Okay, conclusions and future direction. So, yeah, this is all about the gradient boosting algorithm. I will say the theoretical plot, part, black box, everything we have learned, right? So, next session is gonna be a very much interesting and a happy session for me. Like, we're gonna see the coding part of this uh, gradient boosting. So yeah, this is all about today's session. Please guys, please make sure just watch this video. Any doubts that you are having related to data science, you should not be like only completely related to this. It can be any doubts related to data science. Just ping in the comments. We will take up and we will answer your queries. So questions, and then if you have any queries, just ping us. Like, because like we are just trying it out and we are just making. If something is wrong or something we need to improve, we are just open to improve. So yeah, that's all about today's session, guys. Thank you, guys. Thank you so much. Like, until next time, we'll all meet. Like, until the next session we are having, right? Tomorrow. Okay. Until then, bye, guys. Take care. We will all meet in the next session. Bye, guys.
Bye bye, guys. Do the reinforced learning. Go watch all the session 5 to 10 times and press the bell icon. Also subscribe to our channel so that you will get notification for each session, and build your long-term vision for with persistency, consistency and perseverance and long-term vision, and keep learning deeply. Okay, now I think you're sufficient if you've reached to this level. So now let's go deeper and go deep at meta level and understand these concepts deeply so that we can apply them deeply and we know the limitations of these concepts properly. And thanks. See you in the other section.